Let's say about 4:30 on Tuesday morning, I'm going to go over yesterday's activity, day 26. I was in the building briefly, but it turns out that your math teacher can't count to 10, and I came back on day 9. But it turns out I need to get paperwork anyhow, so it wasn't meant to be me going into school yesterday. Let's take a look at the activity. Dude, why is it not working? Okay. So I usually start out in my homeroom class. Doesn't really matter which module I go to because it's all copied. Again, what we're going to do is we're going to estimate areas and make polygons out of circles. There are 2 activities. I wanted you to do both of them, but if you did one, you still get credit. With this activity, there was a warm-up going up in front. So how would you go about figuring out the area of these 2 and which one had more, which one had a higher area? Eventually, you would realize that the width of these 2 match, but the height doesn't match. Therefore, base times height and base times height, this one would be larger than C. And you take this rectangle, it is a rectangle, it's not a square, and you put it inside B, and you'll notice that it is bigger as well. That B is bigger because it's 6 across, and you got 6 across by about, what, 5? So you can fit it all in there. And this is a 6 by 4, and this is a 6 by 5. So we would go B, A, C in terms of largest down to smallest. All right, in the actual area, the activity that we're going to do, it had your work up there first, and then it had the explanation, and then at the bottom was your warm-up on your actual setting. So your paper started out looking like this, and then we would take a look at the directions, and then get to the actual activity. The activity was relatively simple. What you did was you put you would go and you would set the diameter of the circle and put it down to whichever size you wanted, and then you would go and figure out how many blocks you would need. Oops, wrong one. This one. No. This one. Click. Oh yeah. Boom, boom, boom. All right. So, and then back to the other one. All right. So you would got 1, 2, all right, 3, 4, 5, 6, 7, 8. All right, and then you have this extra stuff. So that's like 9, 10, 11, 12. So for 4, I would put 12, right? So I would go down here and I would go 4, and I would go 12. All right, then I come back up here and I get rid of all of it. All right, let me see if that stayed there. Yeah, it did. And then I would go and pick another one, say like 8, okay? So again, I'm going to go and click. Sorry, I'm going to click these. 3, 4. Let's see what it is. 1, 2, 3, 4 by 4. So that's 1, 2, 3, 4 diagonals. All right, so it's a 4 by 4. All right, so 16, 36, 1632, okay, and then 1, 2, 3, 4. Let me try this again. Let's say 1's right there, 2, all right, these 3 right there. And then 3, 4, all right, so 4 out here. And what do we say for this one? This was 32, so 32 plus 4 times 4, 16. 32 and 16, so okay. So that would go 8 and 48, all right? Let's go 8 and 48, all right? No, I'm sorry. 8 and 48, duh, obviously. I go back down and I'm going to take a look at my my grid lines. All right. Does that look like it's straight? I don't know. Let me take it down to like 2. So that's 2, 1, 2, 3, and 3, 2 and 3, maybe. All right, so I'll put 2 and 3 in there. Okay, now you can see that it's not straight. All right. Let me do 6. Now I said that you would pick 2 sets, right? 2 numbers, and you would pick like 2 and 16, or like 4 and 8, or something like that, right? And then eventually you would work and take a look at other people's numbers and get their opinions on it, right? And where are we at? Let's see where it's all right. So we'll get 2 and 3. Let's do 6. All right, so 6 again. This is 3 by 3, so that's gonna be 9, 18. Because this is 3 by 3, right? So then this piece will come over here, and that'd be 9. So then I double that. That's 18, right? And then I look here. There's 1, 2, or there's like 2, 3, 3-ish in each one of these. So 3 is 12. 3 times 4 is 12. All right. And what I say, 9, 9, and 18 to 30, 6 and 30. So let's take a look. 6, down here, 6 and 30. All right. Notice it's not totally straight. Okay. Let's go up to 10. Let's do a large number. Again, it looks like it's a lot, but it's really not. Okay. 5. So this is a 5 radius. So 5 by 5 is 25. Okay. So this will be about 25, 50. All right. Then you get a little interesting. Okay. So I could put like a 3 by 3. So that's 9. So 3 by 3 right there. I mean, yeah, I'm giving a little bit there, so it's okay. And remember, I still have this little piece left over on each one of those, this one and this one. All right. So 5 by 5 is, this comes over here. That's 25. All right. So that's 50. A 3 by 3. So that's going to be 9 and 9. It's 18. So that's 68. Let's go 1 on each of these. 1, 2, 3, 4, 5, 6, 7, 8. So 68 and 8 is 76. Okay. 10 and 76. All right. Want to get a little scary? Do like 15 or 20 or something like that. 20, you know? So it's a 10 by 10. All right. So that's 100, 200. Okay. And then a 3. No, I got to do more than that. 3 right there. 3 right there. How would that go? Let's see. 1, 2, 3. So that's a 9. All right. 1, 2, 3. That's going to be a 9. All right. So 3 by 3, that's 9. So that's around. Okay. So 10 by 10, 200. That's 100, and then it's 200, right? So 9 by 3 by 3 is going to be a 9. So that's 236. All right. So 1, here's a 50, there's a 50. So there's 200 right there. And then this is, again, a 3 by 3. So it's going to be a square, right? Square. And so that'll be a 9. And then you got to do it 4 times. So 3 more times, 4 times total. So that's 236, right? Now let's take a look. Now, if I take this 9 right here, 3 by 3, let me just go 1, 2, 3, 4, boom, right? There's a 9 right there, okay? Now I gotta take out 2. So here's those 2. 1. Again, I'm gonna compensate and take this one out. All right, oh, and this one out. Sure. That's a weird way of doing it. All right, so, okay, so there's a 9, and here's a 9, and these are compensated out. So that's 18, all right? So now where it was 36 going around, that's 18 times 4, which is 72. Yeah, 36 times 2 is 72, right? So that's 272, okay? Now I got this extra stuff, all right? So that's going to be 3. That'll be 3. This on 3 and 3, all right? So 12. Let's go 12, right? So 12 and 18. So this is 30 altogether. So 230 times 4 is 320. All right. So let's take 320. All right. 20, 20, and 320. All right. Now, if you notice, it's going like that. Right. And this is not a straight line. So how is it similar? Well, it's y over x. The area over the diameter, it's y over x. The difference is that it is not linear, therefore it is not proportional. Okay, so the diameter and the area are non-proportional to each other, whereas the circumference and the diameter are. It goes up in a nice straight line. All right, so what you would do is you would go and take a screenshot of that, right? Yeah, chink, chink, tink, tink. And then you would go and pop it into your activity. And I'll show you what it looks like. 26. All right. Let's see what this does. And yeah, so you would put these in here, right? I would put my screenshot right here. I got to get rid of some of these stuff. Yeah, I have my lessons all the way up through November. So if you want to know what we're doing up through Thanksgiving, you can look it up. All right, so I put my screenshot in. Here's my screenshot, right? Now, I can go back in there and fix these numbers, put them in order. How's the graph the same? Like I said, y over x, how is it different? It's non-linear, it's non-proportional. It's actually called parabolic or quadratic. These are terminology that you will get into big time in 8th grade, but you don't have to worry about it at all in 7th grade. So it's a good thing. So you want to put in these numbers down here. We said 2, 4, nope, 4, 6, 8, 10, and 20. Now it's kind of ironic that they go like that, but I did not do that on purpose. So 3, 12, 30, 48, 76, 320. 3. That's my Kid Cudi. Oh no, Kid Cudi comes on later on. 12, 30, 76, something, something. No, 8 is 48. Sorry. 48, 76, and 320. All right, area over. So 32 over 2 is 16, 7.6. 48 over 8 is 6. 30 over 5. 30 over 6 is 5. 12 over 3 is 12 over 4 is 3. And 3.5 is 3.5 or 1.5. But Ricardo, you didn't show your work. That's correct. I did not. And as I was doing it, I was thinking to myself, you're not showing your work, Ricardo. You have to show your work. So even though I myself don't always want to show my work, you still got to do it, because if you don't have work shown, how am I going to give you partial credit if you get it wrong? How am I going to know you didn't copy it? So are they proportional to each other? I'm going to go with a big fat no. Boom. All right. And that's it. Okay. So how are they the same? Y over X. How are they different? They're non-proportional. All right. Then you go to the next one. I'm going to get rid of all this. Jump. And the reason why I'm getting rid of all this is because that saves as is. All right. So we got rid of it. All right. So that's the first one. So that's day 26. Okay. You can stop the video if you didn't do the second one, or if you don't want to do the second one. If you want to do the second one, all right, this is going to be the second part. All right. So 4 kids did that in my homeroom. All right. Remember, if you do the work, you get the credit. You don't do the work, you don't get the credit. You don't do enough of the work, which one would tell me, I'm Mr. Ricardo, you weren't there. I can't be doing this stuff if you're not there. That's what the videos are for. It's the best thing I can do. All right. So then you go to the second one, relating areas to circumference. This is making polygons from circles. Basically, you take a circle and you cut it up, and it turns into a polygon. You do it enough times, it turns into something that's very similar, something that we understand, we know that. So take a look with making polygons, all right? So day 26, making polygons. All right, cool. All right, so this is something that I wanted to do yesterday, but I wasn't there and we didn't have time. So what you want to do is you want to get something circular, anything circular, you can, right? Whatever. Put it on a piece of cardboard, cut it out, 2 different colors. How do you have colored cardboard if you don't have colored cardboard? Well, it's simple. You get a piece of white paper, you circle, you put a circle on there, and you color it, right? I don't have any pen, I don't have any color. Oh no, what do? I take a pencil and I shade it in, and I keep the other one white. Oh my God, I don't have any pencils. All right, so I get dirt, and I put the dirt on there, and then I leave the other one white. Oh my God. All right, so in any case, that's how you do it. All right, non-linear thinking. So then you're going to cut them out in fourths. Chop, 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 chop. All right, and then you're going to lay them out on opposite colors of each other with one long side and another long side and then another long side and another long side. And it's going to start making something, right? So we didn't do that, right? So this is what we're going to do. We're going to go over to this nice GeoGebra. GeoGebra, it's like Kung Fu, right? And we're going to go down to 4 sectors. All right, we're not going to go to 4 sectors because it won't let us, all right? So we'll go to 12 sectors. If I were to cut this part, right? 4 sectors, right? If I were to cut it apart, right? And then line it up, what is it going to look like? It's going to look like the NBC Peacock from the 60s. NBC, no, hold on a second. I did that wrong. All right. NBC Peacock from the 1960s. See if I was right. Nope. I don't remember what it looked like. Maybe it was the 50s or the 70s. Maybe it was the 70s. I don't know. 1970. 1950? 1940? 1930s? Brady Bunch symbol. No. I don't know. I've lost my mind. I don't know. But I remember a little like bird going to Partridge Family. That's what it is. Partridge Family. See, there you go. Partridge Family. Boom. Got it. And you're like, what is that, Ricardo? I have no idea what it is. Ask your grandparents, because your parents are probably about my age, and I don't know if they were forced to watch 1960 shows in the late 80s. I don't know. Maybe. I did. I had to. All right. So anyhow, you take this like this, and it doesn't really look like anything that we kind of understand. So then what you're going to do is you're going to put it back, treep, and you're going to go hoink, and you're going to bump it up to 8 sectors. Now that we would do this too. So then we got our 4, and we would paint it, and we like, it looks like a squibble thingy. And then we're going chop it into 8s, right? And we do the same thing and go fada, right? And that looks weird, right? But if you take it out of the circle and put it into, stretch it out, it's starting to look like a polygon that you may know. Now, if you were to go free to like 120 sectors, and then you would go white, now it is a polygon that you know it's a rectangle or a parallelogram, all right? Because if you want 100, if you went to like 50 or so like that, and you left it down, it's more like a parallelogram. But if you bring it out to about 120 sections, like it looks like a parallelogram. Now, if you take it as a circle, you would notice that it's that this circle right here is half of the circumference, and the height is the what do you want to call it? The radius, right? So an area of a circle would be half the circumference times the radius. Now, let's come back to our activity. All right. How do the two areas of the two shapes compare? All right. Well, they're the same, like the parallelogram and the circle, they have the same areas. And what when you cut them out, they have the same areas. But you can come up with them with different formulas. All right. What polygon does the shape made of the circle pieces most resemble? You want to say parallelogram, but it could be rectangle. Could be rectangle. How can you find the area of this polygon based on the height? All right. Which represents the shape they constructed of circle pieces and how they know? That question sounds a little like redundant, but it still looks like a parallelogram, and that's based on type. And base is the circumference, half the circumference times the height, which is the radius. And then another way you can look at it is you can take a circle made out of rings and you can cut the rings, and it unfolds, right? And what does this make? This is actually supposed to be the animation, but it didn't work. So you can watch the animation right here. You go to it, and you go down, and there it is right here, right? So when you choppy, boop, choppy, all right, the height, again, is the radius, and now this is a triangle, so half the base times the height, okay? What polygon does the new shape resemble? That's triangle. How does the area of the polygon compare to the area of circle? Half the base times the height is equal to half the circumference times the radius. So half the base, which is the circumference, half of that, half the base of the triangle times the height, right? How can you find the area of the polygon? Let's do the math, right? Showing details as to how you could find the polygon's area in terms of the circle's measurements. This one would be, you would get the flat piece, which is the circumference part. All right, the exterior, and you would take half of that and multiply it by the radius. All right, so radius. So let's see, after finish, so polygon. I'm trying to do this in my head, and I need to do it on paper. How does the area of the polygon? So half the base times the height, base times the height is equal to half the circumference times the radius. All right, how can you find the area of the polygon? Half the base times the radius. Half. Yep, that's right. Yep. No, I want that like that. All right, CR. All right. How does the area compare to the area of the circle? The triangle, the circle, when it's unrolled, it becomes like a triangle, right? Basically, all right? It's almost like a triangle. Show in detail how you can find the polygon's area in terms of the circle's measurements. Show your thinking. All right, so half the base times the height is equal to half the circumference times the radius. So half the circumference is d pi. D times, no, D, sorry, D times pi, and that's alt. Put that over here. Pi command is alt plus P at the same time. All right. So times the radius. Okay. Now the D, so 1/2 times 2 times the radius times pi times the radius. Okay, so that right there, 2r. I'm sorry that it's small. I'll make it bigger. Right, half circumference. Right, so this was the circumference. Right, nope. That's what I want. All right, I'm gonna put that as like red. Right, all right. Half the base. This is red. Okay, becomes the diameter times pi. That's still red, right? And again, the diameter is still right there, right? Yeah. This is still the circumference, right? Now, if I were to break this apart, all right, I'm going to break that apart. So 1/2 times 2 is equal to 1, right? And then r times r is r squared. So it's equal to pi r squared. And if you want it better, you can go like this. And you'll put the 2 and the font. Nope, not that. Make this bigger. Nope. Where's that? I don't know. Where's the superscript? Can I make superscript? Superscript. Paragraph, text, superscript. There you go. Command. Oh, command circle. No, command, not circle, period. All right. So pi r squared. Okay. So now you have how to make a circle from cutting it up when it was a triangle. Why do they make you do that? Because that's the new math. All right, after you read, you're going to take a look at everybody's work. Well, you can't do this. So this part is like done, right? So after you get done 4, pretty much that's all you can do, right? And that is the activity. It's real simple, which represents the shape they constructed for what's it for? Showing details how you can find the areas. I don't understand where this question came from. I didn't make it. Did I? I don't know. I don't know. But, oh, they're two different sets of questions. Duh, two different activities. Yeah. All right. That makes sense. All right. So you can do either of those, this one or this one. But it kind of works to do both. All right. So that's about 5 o'clock on Tuesday. If you see me later and I'm like this, it's because I've been up since like 1. I don't know why. Probably getting over what I got. All right. So I shall see you when I see you. Deuces.